Welcome. In this video I talk about async functions and asynchronous methods. Asynchronous programming is very important to get performance critical stuff running, but it's not always useful. Sometimes asynchronous methods can be hard to understand, so therefore in this video we take it easy. I will only show you how to use asynchronous functions. I will not yet show you how they work behind the scenes. We reserve that for a later video. To begin with, we start by introducing an asynchronous function. An asynchronous function is written like a normal function, except that I put the async keyword in front of it. Now, the meaning of this is that it is an asynchronous function, so it does not actually return the type I indicate here. Rather, it returns a future templated over this type. A future is an object which represents the future result of this function. You cannot just call async functions. Rather, you need some kind of executor or runtime to execute it. For this first example, I've used the simple-most runtime I can have, namely the one from the futures crate, like here. This enables me to import the function blockOn, and here in my main function where I have standard synchronous code, I can just say blockOn, and then I take the result of this future. So what happens here, I pretend as if I call f, note that this asynchronous function doesn't immediately run, rather it returns a future which I can store in this variable. So the type here is future with output i64. As you will see in a second, I then print something to indicate that the code is not actually executed in this function here. But if I pass this future to the blockOn function, then this executor starts to execute the asynchronous function. I will see the hello f, I will compute the sum and get the result here. So the type here is the actual return value I've put here. The future is dissolved because the blockOn function has waited until it's executed. So what we are going to see is here first hello, then hello f, and finally done. So let's run this. Indeed, hello, hello f, done. So let me reiterate. If I pretend to call this function, I get back future with result type i64. Then the code above is not executed, and only if I pass this function to an executor, only then it will be executed, and then I get the result here. Now, our next example, I call asynchronous functions from an asynchronous function. So this is exactly the same main program. I again use the blockOn executor. I pass it the function f, but then I call another async function, g, from f like this here. Since I'm now in an asynchronous context, I can use the await thing. Notice if I would just call g of a, I get a future. But if I take a future and await it, then what happens is that this asynchronous function will be suspended, and the executor will execute the future in this g function here. And once that is terminated, it will return, and AA is indeed just an integer. So I can write synchronous code basically with this await syntax, but behind the scenes, the compiler generates a state machine for f. This state machine will run for a while until it is suspended. Then other stuff can happen, for example, here the function g. And once this is terminated, then the state machine goes on here and executes the next bit. So what I expect here is that I first see hello f, then I see hello g, then I see hello f2, then I see again hello g, and then f3, and only then I get block here. And it's the runtime which manages all these futures and all these asynchronous functions to be executed in exactly the right order. Let's run it. So indeed we see f, then we see g1, F2, G2, F3, and in the end we have the result 5. So take away from this example, within an asynchronous context, you can do a wait. It's not possible in a synchronous context. And that suspends the execution of this F here and waits until the execution of G has finished. What we have seen so far doesn't allow for the concurrent running of multiple asynchronous functions. If I want to do some multiple things basically concurrently, then I have to do something else. In this example, I run the same function f, asynchronous function, as before, with the difference that I first schedule 2 calls to G, and then I ask for join to wait until both of them have executed. Yeah? And to make this even more impressive, I start 2 of these Fs at the same time. So my point is, if I do this here, I start multiple asynchronous things in the background. Since they do not immediately run, this join here will have the effect that they are done one after another, because it will first join A and then join B. So this doesn't give me concurrency. But if I ask for a thread pool with multiple threads, and I use spawn OK to spawn things, then they actually run concurrently. So that's why I've chosen the values 1, 2, and 3, 4 here, and I sleep for a duration of 1 second in C here. So let's see what happens if I do this. So you see multiple steps, each a second apart, and in the end it waits for 10 seconds. So if you look at the function G, G1 and 3 have now been executed concurrently, and a second later I got G2 and 4. And only then everything finished. Let me just run this again. 1 and 3, 2 and 4, and then all is done. And after 10 seconds everything ends. Let's understand why that happens. These two futures, or these two asynchronous things, the calls to F with these and these arguments, they happen concurrently because I have spawned them in the thread pool. The outer thread here just waits for 10 seconds for everything to complete. However, when I then go in one of these in there, then F schedules 2 things after another directly, but the join macro will only wait and pull them for completion one after another. And that's why we see exactly here what we see. For our next example, we use the Tokio runtime. To begin with, I have used a different crate. This time I used the Tokio crate with all features. And I have annotated my main function with this hashtag Tokio main, and I've made it asynchronous. So this time already my main function is in an asynchronous context. Therefore, I can just await futures. And for the sake of explanation, I've here created 2 futures and then awaited them one after another. So let's see what happens then. To illustrate the time going by, I have now made it so that this G function waits for C seconds if C is the argument. So we expect that it's first called with 1, and then with 2, then with 3, then with 4, since these here are sequential. So let's see what happens. 1, 2 for 2 seconds, 3 for 3 seconds, 4 for 4 seconds. Why is that? Yes, I have started the 2 futures or asynchronous functions here right after one another. But as you know, without being awaited or without some executor working on them, they are not executed. So in particular, the G call for the 1 and for the 3 do not start concurrently. Rather, what happens is that when I do this await here, the main asynchronous function is suspended. We start with the f for 1 and 2. That calls g, and therefore we see first 1 and then 2 being worked on in g. Once this is done, we are back here, we write hello 3, and then we work on the second. So keep in mind, futures, asynchronous functions are only executed if somebody is awaiting them. Some executor is working on them. If I wanted things to run concurrently, then I have to use Tokio spawn. The default runtime of Tokio is already a multi-threaded thread farm, essentially. Therefore, I can run multiple things concurrently. So here, we have the effect that the asynchronous functions or futures here are ran immediately. So G for 1 and G for 3 will start concurrently and will execute concurrently. The fact that I await here, in this case, when I await for something spawned, I have to get a result. It could have gone wrong. Therefore, I have to unwrap here. I ask for the result X first and then for Y. And then I terminate the whole program. Let's see how this runs. You can see 1 and 3 are already started. 3 takes longer because it takes 3 seconds, but then 2 comes and 4 basically also running concurrently. So here we have proper concurrency. That's because I have spawned an asynchronous function. So we have now seen you can just call an asynchronous function, getting a future, and then await it to run it. Or you can spawn a future such that it's run in the background, and then you get something like, which is called a join handle here. And the join handle also has the return type baked in as a template parameter. And then you can await the join handle and basically wait until this background operation has finished. To give you a better understanding of what the Tokio runtime does for you, I've here not used the annotation for the main function. So the main function is a perfectly normal synchronous context. So what happens behind the scenes if you do this annotation, you create a runtime. Here I create a new default runtime for Tokio. That's essentially starting a thread farm in the background. And then I use the block on method for this asynchronous block. So here is an asynchronous block. It's not quite a function. It's a block, which is an asynchronous context. But I execute this as if it were an asynchronous function. This does exactly what we just saw. We spawn something in the current Tokio runtime, and we await it to finish. So this is essentially the magic which Tokio does for you if you use the main annotation. Why is this important? Well, as you have seen, we always need an executor or a runtime to execute asynchronous functions. So if you are in a synchronous context somewhere in a function, then you need to do something like this to get yourself a runtime, and then you can execute an asynchronous context. Whereas you can always call synchronous functions from asynchronous ones. So this does exactly the same as the previous program. I hope you got a first impression how asynchronous functions in Rust are written and used with the await method and with runtimes. Presumably the most convenient one is with the Tokio runtime. You have seen when things are running one after another sequentially, and you have seen when things run concurrently, and we will see in more videos more examples of these things. In a future video I will also explain how asynchronous functions behind the scenes work. That's it for today. See you in the next one.